Docker is a tool designed to make it easier to build, ship, and run applications by using containers. So how does it work? Let's have a look. A developer packages a whole application with all of its libraries and other dependencies as one single package. This package can then be easily shipped and deployed at single or multiple customer sites. Another advantage of Docker is that it provides a lightweight and fast environment to run the code in a predictable manner. So what's the objective of this course on Dockers? Let's have a look. This course will help you master Docker and clear the Docker Certified Associate exam. In addition to covering the contents in detail, we will also discuss the test formats, what to expect in the exam, how to prepare, and pitfalls to avoid while preparing for the exam. In essence, we will cover almost everything under the DCA, which is Docker Certified Associate Exam Study Guide. So, without any further ados, now let's begin this wonderful journey of learning Dockers. Hello everyone. In this module, I will introduce you to a concept of Docker. Docker is a containerization platform, which means it first allows you to bundle a full-blown application as an image. Now this image then can be run as a container on any host which is running Docker. It very easily fits into the continuous integration and delivery model of DevOps, as the Docker images can be built in an automated manner, pushed to a Docker repository or registry, and then containers can be run from those images. We will cover these topics in detail as we proceed further with the course. Now, Docker containers are extremely fast to come up, with most of the containers having the startup time less than a few seconds. An inherent property of Docker container is that they start always in the same manner. Docker host is the machine, physical or virtual, on which the Docker is installed. Multiple containers can be run on a single host machine. There is an isolation maintained between the individual containers using namespaces and control groups behind the scenes. As we all know, microservices based architecture is increasingly gaining momentum, and it is fast replacing the monolithic application building style. Docker is a key technology for managing and deploying microservices. A container is a unit providing a single service. So you can look at a container as one single service. Rather than having just one replica, Docker allows us to run multiple replicas of a container. This provides the required capacity to the service and also adds a level of reliability to these services. Now let's have a look at a diagram which will explain this thing even in further details to you. Now in this slide, let's talk a bit about Docker containers. A Docker container is a running instance of the Docker image. So you have a Docker image which has all the prerequisites bundled all together. That is, the libraries and binaries already packaged in itself. The Docker image is easy to share. You get the Docker image onto your Docker host and you run it. That running instance which provides you the desired service is the Docker container. Now the image doesn't provide you anything until you run the container from it, right? So now take a look at the diagram on the slide here. You need to have a host operating system on the infrastructure that is to be used. Docker engine is installed and runs on that operating system. Docker uses operating system level virtualization for running the containers. Each container shares the kernel of the host operating system only. They just add user space on top of it. Now, one container is isolated from the other running on the same host. Even though they have the same kernel, each maintains its own space. That is, there are boundaries defined and they are followed by all the different applications and the containers that are running on that host machine. Conceptually, this all sounds similar to virtual machines, isn't it? But it is not entirely true. Containers are not just lightweight virtual machines. There are fundamental differences in these two technologies. Virtual machines run on hypervisors which provide virtual hardware resources to each of the virtual machines. Each virtual machine has its own operating system running on those virtual hardware resources. Now, whereas the containers just have their own set of libraries and binaries, as we have seen, they share the kernel of the host running the Docker engine. A container provides the user space of an operating system. Hence, containers are an abstraction at the application layer, whereas virtual machines provide abstraction as the physical layer. So the abstraction is provided at the application layer in this containers concept. Hello everyone. In this nugget, we will talk about why Docker is generating so much interest right now. What are the benefits that it provides? Firstly, it's a convenient way to package applications. All the dependencies, libraries, and prerequisites are already taken and bundled in the image. No need for a long installation manual to be shipped along with the software. It integrates very well with the continuous delivery model of DevOps and building of the software, followed by shipping, and can easily be automated. The images are in the ready to run state, which can be straight away deployed at the customer end. We will cover this in detail a little later, but as useful information at this point, when a newer version of the container replaces the existing container, the data isn't lost at all. Also, the transition to the newer version happens only when the newer version is up and running. In a traditional scenario, when the software is shipped with a list of deployment instructions, how many times do we have seen that there are issues in production which are never observed at the development or test environments? I'm sure you all would agree to this, that we do see these kind of discrepancies. In case of Docker containers, all the environments are just the same. What works in development will work in the production in the exactly similar manner, because the underlying layer of Docker remains the same everywhere, whether it's test, production, or deployment environment. Now, the Docker works in cloud deployments as well as on-premise based deployments with equal efficiency and effectiveness. As we have seen earlier, it provides a lightweight and faster alternative to virtual images. In this slide, we will talk about a bit about the history behind the Docker and its competitions. Docker Inc. is the company which owns the Docker software. It is based in San Francisco, California. The company was founded as .cloud in 2010 by Solomon Hykes and was renamed to Docker in 2013. Linux Containers, also known as LXC, provides utilities to run and manage containers. Initially, Docker used LXC utilities, but then later it switched to libcontainer. Libcontainer provides an interface to Linux kernel facilities like C groups and namespaces, and is written in Go programming language. Now, C groups or container groups and namespaces are the basic building blocks of the containers. So now, the question is the Docker only solution for containerization? Definitely not. Jails from FreeBSD is also an implementation of operating system level virtualization. Its mechanism restricts the activities of a process in a jail with respect to the rest of the system. LXD is a container hypervisor, so that we get the LXD containers in much closer to the standalone operating system. If you compare it to the Docker container, it is followed and promoted by Canonical Limited. Next, LMCT-FI is yet another implementation of operating system level virtualization. It is based on the Linux kernel's C groups functionality, which we know is also used by Docker. It is open source version of Google's container stack. They are kind of collaborating with Docker on the libcontainer. Now let's talk about some distinct advantages that Docker provides. Firstly, it is open source. Docker supports a variety of Linux distributions, Mac OS, and even Microsoft Windows. Newer versions of Windows now support Docker natively. You can run Windows container on Docker as well. We have smaller base images like Windows Server Core and Nano Server available to use, and we can build applications on top of this. It is really cool stuff. Otherwise, containers were generally synonymous with Linux applications. All the major public cloud vendors have support for the Docker. So be it Google Cloud Platform, Amazon Web Services, Microsoft Azure, IBM Cloud, etc. They all are supporting the Docker. For production environments or big deployments, you need orchestration engines, as you cannot manually manage and monitor the container processes. If you have selected Docker as the container platform, you have the options of Kubernetes, Docker Swarm, Marathon on Mesos, to name the major ones. OpenShift is an open source container application platform built by Red Hat, and it is based on top of Docker containers. Apart from the Docker team, there are biggies like Cisco, Google, Huawei, IBM, Microsoft, and Red Hat, which are also contributing to Docker.